Okay, so we're going to start today with writing equations from tables. You're going to see those same terms that we talked about yesterday, the independent and dependent variable. You're going to see the same terms. All right, so we are still going to see those same vocab words, independent, dependent variables today. That's why I wanted to introduce it yesterday. I did not expect you to be super experts with identifying which ones are independent, which ones are dependent in the first day. We're going to do more practice with that, and we're doing more practice with tables and graphs today. So first thing I want to do is fill in the blanks at the top part. It says the relationship between two variables where one variable depends on the other can be represented in a table or the other can be represented in a table or by an equation. So this whole page of notes is just looking at equations and tables. We don't have graphs yet. That's next. Usually X is the independent variable and Y is the dependent variable. We learned about that yesterday. Independent is the X, dependent is the Y. The value of Y depends on the value of X. Okay, so let's look at what this might look like in equations and tables. Okay, so I'm given three different tables. I have my X values, I have my Y values. I want to find the relationship from X to Y. So what is happening, looking at this very first table here, what is happening to get from X to Y as I go down my table?
-2.
I'm subtracting 2 each time. So my equation is Y equals X minus 2. Is everybody with me so far? In order to get Y, which is 10, I have to do X, which is 12, minus 2. In order to get Y, which is 9, I have to do X, which is 11, minus 2. Is everybody with me? Yes.
Wait, do you ever do X equals Y plus 2? Oh, yeah.
Usually you're solving for Y. Like when we start going into algebra and we are looking at graphs, we're typically looking at Y equals because Y depends on the X. So because X is independent, that's what I'm manipulating in order to get my Y. I'm usually solving for Y because it depends on whatever X is. Does that help answer? Okay. That's why it goes back to that independent, dependent variable. Okay, the next one, looking from 1 to 2, 2 to 4, 3 to 6, what is happening? I'm doing 2 times X. So my equation is Y equals 2X, or is there anything wrong with writing Y equals X times 2? No, you can do that too. But it looks a little confusing. It would look like this. There's nothing wrong with it, but what you will see in algebra is you will typically see it written this way. Okay, so we want to make sure that we are really making sure that our X and our multiplication symbol aren't confused with one another. Okay, the last one, to get from X to Y, what am I having to do to the X? I'm doing Y equals X divided by 5. I could also write it this way. Y equals X divided by 5. Another way that you could write this is Y equals 1/5 X. Just want to give you another example. How come that works also? If I take 1/5 of X, how is that the same thing as dividing by 5, Brant?
Because if you said 1/5 of this, that would be 2.
Exactly. So any of these is the correct way to write that. I would accept any of those. Okay? Okay. Marty earns $8.50 for 1 hour working at the snow cone stand. He wants to earn $34.36 for a new video game. How many hours will he need to work? Okay, so the first thing that we're going to do is we're going to label our table. We always want to make sure we label the table. So the first thing I'm going to put here is H for hours worked. And we're going to label, our variable will be X, because we typically have X and Y. We're going to stick with X and Y because that's what we're going to use next when we start graphing, because we have the X axis and the Y axis. So we'll just keep it all consistent. So that says hours worked. And then on the right side, my Y column, that's going to be money earned. Okay, so what do we know? What do we know from this word problem? Okay, so in 1 hour, he gets $8.50. Do I have enough information to finish my table? Yeah, I have plenty of information. So then if I did 2 hours, that would be $17. 3 hours would be $25.50. 4 hours is $34. And 5 hours is $42.50. Now, the part that I'm missing is my equation. How do I come up with my equation? Y equals what? What am I doing to X? Each time.
Adding $8.50.
Am I adding $8.50 to X? So if I do 2 plus $8.50, that's how I get 17?
No,
I'm multiplying by $8.50. Good. So it's going to be $8.50 X. Okay, are we good on this page? Just pulling out equations from tables, like just finding the rule. All we're doing is looking at the rule from X to Y and saying, okay, I subtracted 2 from X, so that's my equation. X minus 2 is Y. Or here I have to multiply X times 2 to get Y, so 2X equals Y. Here I'm dividing X's by 5, so it could be any of these equations. This one, I'm multiplying X times 850 each time, so it's Y equals 850X. Okay. So now, same thing, we still have tables, and we know how to plot information from tables onto a graph, so we're combining everything together. An ordered pair, just to remind you, is going to look like this right here, X comma Y. X comes before Y in the alphabet. We do X before Y in an ordered pair, always. Okay, that makes an equation like Y equals X plus 1, true. An ordered pair like XY that makes an equation like Y equals X plus 1 true is called a solution to the equation. So an ordered pair like XY, or maybe I actually want to plug in a value, maybe it's 1, 2. If that made an equation true, then we would call that a solution to the equation because it's true. It worked. It's an answer. It's a solution. The graph of an equation represents all of the ordered pairs that are solutions. Okay, so we have steps on how to graph an equation. You usually want to start with a table because you're going to want to make sure that you have ordered pairs to graph. If I don't have ordered pairs to graph, how in the world am I going to plot a point? So we're going to start out with a table first. And I typically like to start with either 0, 1, 2, 3 or 1, 2, 3, 4. We just kind of go in that order, start with low numbers. Okay, so we're going to make a table of values, choose some values for X, and use the equation to find the values for Y. Okay, Okay, we just looked at tables and we figured out the rules from a table. We learned how to write an equation from a table. Well, if I'm already given the equation, I'm going to make myself a table. So I'm going to go ahead and just say, let's just use 1, 2, 3, 4. Those are easy numbers to plug into an equation. So what I'm going to have here is I'm going to plug in 1 where I see x. So it's going to look like this. 2 times 1 plus 2. What is 2 times 1 plus 2? 4. So what is my x is 1, my y is 4. Do y'all see my equation here? I'm solving for y. So I have to use this in order to figure out what y equals. And then I list it like an ordered pair. We're going to do it again 3 more times. So if you're almost there and your bulb is flickering, we got 3 more. We're going to do it 3 more times. Okay. Here, 2 times 2 this time. Why did I plug in a 2 here? Because x is 2 this time. Don't forget to add 2. So what is 2 times 2? 4. And then plus 2 is 6. So that means that my ordered pair is 2, 6. Okay. The next one, 2 times x will be 3 plus 2. So what's 2 times 3? 6 plus 2 is 8. So when x is 3, y is 8. The next one, 2 times x is 4 this time. So 2 times 4 is 8 plus 2 is 10. So when x is 4, y is 10. So there's my ordered pairs. Now I can graph this equation. So we're going to plot my ordered pairs. Do I have any numbers on my graph? What do you think we need to do first?
Add numbers.
We need to add some numbers. So I'm going to down here do 5, 6, 7, 8, 9, 10. My y, I'm going to go up to 10. And now I can plot my points. My first ordered pair that I want to plot is right up here at the top in my table, 1, 4. So I'm going to go over 1, up 4.
What are we labeled in?
We don't have a title for it right now. When we start comparing different quantities, we will. This is just giving you an example. Okay, next, I'm going to plot 2, 6,
I did it.
then 3, 8, and last will be 4, 10. Step 3 says draw a line through the points to represent all of the ordered pair solutions of the equation. So it'll look like this. Now, something I want to point out to you. Notice how it's not starting anywhere except for in the middle of the graph. There's actually a starting point for this. What if I had done 0 up here? If x is 0, what would y be? 0. Think about it. I multiply 2 times x and then add 2. It would be 2. So where would that point be if I plotted it here? When x is 0, y is 2. So you could actually start it from the y-axis. When x is 0, think about it. When x is 0, 2 times 0 is 0, but then I add 2. Y is 2. Okay, this is what your practice is going to look like today. So we are going to do one. You only have 2 like this. You just have 2 like this. We're doing this one together. And this one's kind of hard because it's adding. The other ones are simple. It's just like a one-step equation. Okay, Zoe is shopping for fruit at the local farmer's market. Guys, if you're talking, please listen. Okay, she knows that she wants to buy a bushel of peaches for $12 plus some plums. Okay. Okay, so I know I'm gonna have $12 plus something else, but I gotta figure out how I'm gonna represent what I'm paying for plums, okay? Plums cost $2 each. We're gonna make a table and a graph to show her total cost, which is represented with T, when she buys 1 to 6 plums. So it's giving us a range to use in our table. Don't forget to label our axes. Okay, so first, my dependent variable. Is the number of plums I buy going to depend on my total, or will my total depend on how many plums I buy?
Your total will depend on the plums.
So my total T depends on P plums. Because if I only buy 1 plum, then my total will be less, versus if I buy 6 plums, then my total will be more. So my total depends on how many plums I buy. So my equation will look like this. This one's a little different than the ones you're gonna have because it's a 2-step equation, meaning that I have to do, plums cost $2 each. So it's gonna be 2P, 2 times a plum, however many plums. But remember, she bought a bushel of peaches for $12, so I have to add 12 to whatever my plums equal. Okay, yours are not gonna have the addition part today. It's just gonna be the multiplication part today. All right, so let's look and see what we have to do. For this, the first thing that I wanna do is label my table. I always start with the table because I've gotta figure out what my ordered pairs are. I can't go straight to the graph. I've gotta get my ordered pairs first. So I'm gonna label my table, and I'm gonna have number of plums here, and then my total over here. So what am I using to represent plums? What letter?
P.
P, okay. And then my equation was, to figure out the total, is 2P plus 12. Okay, so I'm just gonna put those there at the top, so just as a reminder. And now I can write in, what numbers did it tell me to use for the number of plums?
$2.
1 through 6. So 1, 2, 3, 4, 5, 6. All right, now, do I have enough information to figure out my totals? Yes. I have 1 plum. Where do I plug that in? Into the P. So I do 2 times 1, which is 2, plus 12 is 14.
$14.
So what I did was 2 times 1 plus 12. Okay, this time I'm gonna plug in 2, for P. So 2 times 2 is 4, plus 12 is 16. Now I'll plug in 3 for P. 2 times 3 is 6, plus 12 is 18. Then 2 times 4 for P, plus 12 is 20. I'm going to stop writing that part out because I think we're starting to pick up on it. But if you'd like to keep writing what you're plugging in for P, you can. The next one would be 22, and then last would be 24. Okay. So now we move on to graphing that equation. Okay. So over here I have my total cost. I didn't give myself enough room to write on that line. I have total cost over here on the y-axis. So what is my dependent variable? What's my x-axis? Yep, the number of plums, because that determines what my total cost will be. My cost depends on the number of plums that I buy. Okay. I'm still missing something on my graph. I am missing numbers. Each line can actually be represented as 1. So do you see how there's like little bitty lines off to the side here? They're skipping. These are like counting by 4s, because if you count up, this is 1, 2, 3, 4. So I'm going to label 4, and then 8, 12, 16, 20, 24. And same thing on the x-axis. 4, 8, 12, 16, 20, and 24. Because they're counting by 4. Those little tick marks are every 4 spaces. Okay. Now we started at 1. But if I didn't buy any plums, what would my total cost be?
0.
Oh,
12.
it would be $12 because remember the peaches are $12. So I would plug in a 0 where P is, and 2 times 0 is 0 plus 12 would be just 12. So this is where my first point would be if X is 0. Now I'm going to plot the rest of my information from the table. So 1, 14. Oh, whoops. Sorry, I don't need to count by 4s on the bottom. Why didn't anybody stop me on that?
I had it there. I was gonna, but you were probably gonna get mad at me.
No, I would have been like, thank you, because then it would save me from having to redo it. Okay. Sometimes y'all do, sometimes y'all don't. Today y'all didn't correct me. Okay. It'll just space out our data better. It'll look so much nicer if we space them out. There's nothing wrong with counting by 4s, but that's kind of unnecessary. Okay. All right. So my first one is 1, 14.
Or no, are we not correcting the sides?
No, the side is right. We want to use that because look at my Y values. I go from 14 all the way up to 24. So I want to make sure that I can get up to 24.
What?
Okay. My next ordered pair is 2, 16. So I'm going to go over to 2 all the way up to 16. This is where my next point will go. My next ordered pair is over 3 up to 18, which is right here where my point is. Then over 4 up 20, over 5 up 22, and last is over 6 up to 24. I did kind of speed up there because I know that you guys know how to plot points. Okay, what am I missing? What do I need? I need to draw my line. And I'm going to draw an arrow to show that if I continue to buy more plums, my rate will continue to increase the same amount.